Okay class. Now we have to see one more point, that when the face is present or the plane is intersecting any axis on the negative side, then what you will do? So let me draw the crystal axis for simple cubic, and let these are along x-axis, y-axis and z-axis. So class, if you see, if you proceed the crystal axis along x direction in negative direction and make a cube, then it will be like this. You see, this is the face in the negative direction, and if you complete it, then it will be like this. So here, this is the face, you see. So this is the cube, which is behind xz plane. Okay class, so I am making here two faces, and you are to see, this is the front face, which is, you can see, this is in the yz plane, and the sides are along y-axis and z-axis. Now think of the plane which is behind this face, and I am talking of this face. You can see, this is the face which is present on the other side, parallel to this face and behind it. Okay class, so you can see, this is the x-axis along this direction. We have, this is the x-axis which is in negative direction, it is the origin. So here we have 0, 0, and you can see that this face is cutting the x-axis on minus a intercept. Okay class, this is a cube of size a. So this point, coordinate of this point is minus a, then 0 and 0. So you can see here. Okay, so if you want to find out the Miller indices for this, then what you can write? Firstly, you will find OX. Okay, let this point is X. Okay, so here the first point is find out the intercept, that is OX, and it is -1 time of the primitive vector along that direction. Okay, now see, this side is parallel to Z, the two sides are parallel to Z. So the intercept on the Z axis will be at infinity. Now this side and this side, these are parallel to y axis, you can see. So the intercept for this face on the y axis is also at infinity. So I can write here OY, this is equal to infinite times of the primitive translation vector along y direction. In the same way, OZ, this is equal to infinite times of the primitive translation vector along z direction. So from here, now these are equal to n1 times of a and n2 times of a and n3 times of a. Okay class. So now in the second point, what you will take, you will find the value of n1, n2, n3, and I am writing them. This is -1, then you have infinity, then again you have infinity, okay. And for the third point, in the third point, what we will do, we will take a reciprocal of that, so it will be 1 by minus 1 and then 1 by infinity, then 1 by infinity. So here you will see in the fourth case you remove the fractions and here you will get minus 1, okay class, and then you have 0, then you have 1 by infinity, it is again 0. Now how you will write these integers in the form of Miller indices? So the Miller indices for this particular face which is behind, which is intersecting the x-axis on minus a, okay. Let me show this face. This is the face, this is the face, okay, okay, which is behind this one, okay class. So for this face the Miller indices will be HKL, this is equal to 1, 0 and 0, okay. And when you write minus, then you will put a bar on that particular indices. So this is how you can represent the Miller indices for a face which is cutting any axis on the negative side. Okay class, now we have different crystal lattice structures, okay, and these are simple cubic basically, and we have to find the planes, we have to find the Miller indices for the planes which are passing through these crystal lattice points. So class, you can see in the first case this is simple cubic and particles are present which are shown by this color. So if we take a plane which is passing through these lattice points, then it will be this plane. You can see this is the face diagonal, this is the side, and this is again the face diagonal of the top face, this is face diagonal of the bottom face, and here we have to find the indices for this plane, okay class. So now what you will do, in the first step you will see what are the indices, what are the intercepts, okay. Classing, this is x-axis, this one is y-axis, and here you have z-axis, okay. And this point is in y-z plane, and this plane is cutting the x-axis at this point, okay. And if this is a simple cubic SC and its size is A, okay class, then the primitive translation vector along x direction, it will be of size A. So the intercept on the x-axis is at A. So I can write the OX, this is equal to 1 time of A. Clear? Now come to another axis, that is y. Here also this is at, see what is this coordinate? This coordinate is 0, A, 0, okay, and this coordinate is A, 0, 0, okay class. So in this way you can see. So along the y direction we have intercept at 1 time of A, and see that the two sides are, these two sides are parallel to z axis. So whenever two sides are parallel to any one axis, any one crystal axis, then that particular plane will not cut that axis. So here z axis is not cut because the two sides are parallel to the z direction. So I can take that the y axis, the z axis, this is cut at infinite distance times of A. So this is the first step. So in the second we will see what are the coefficient of primitive vectors along that particular direction. So here that is n1 is equal to 1 and n2 this is equal to 1 and n3 this is equal to infinity. Okay class. So in the next step what we do, we take reciprocal of these, or you can say you take 1 by n1, 1 by n2, 1 by n3. So this is the first step, this one is the second, and in the third you will take the reciprocal of 1 will be 1, and that of 1 again it is 1, and that of infinity 1 by infinity it will be equal to 0. Okay, now you will put them in, there is no any fraction, if there is any fraction then you will remove the fraction, otherwise you will carry on with same digits. So here we have 1 1 0. So HKL for this particular plane will be equal to 1 1 and 0. Okay class. Now come to the next figure. Here you see that you have two cubes, okay class, and we have lattice points which are shown by this, I think this is pink color. So if you take a plane which is passing through these lattice points and you find the Miller indices, then firstly we will see what are the intercepts on the x-axis, y-axis and z-axis. So this is the plane, and what are the coordinates for this point? Let the size of the cube, this is a. So up to this distance it will become 2a. So a plus a twice of a, and here it is a. So along the x-axis this coordinate will be a 0 0. So here it will be 0 twice of a and then 0, and here it will be 0 0 and a. So these are the coordinates. Okay, now if I make a plane which is passing through these, then you will see this will be the plane. Okay class, and you can see the orientation. Okay, if I rub it, then you will see this is the plane, and this plane, in this plane you will see that no any side is parallel to any axis, x-axis, y-axis and z-axis. So definitely there will be no any intercept at infinite distance. Okay, and these coordinates are finite. You can see this is a. Okay, so the intercept along x direction, this will be 1 time of a, and along y direction it is 2 times of a, and along z direction again it is 1 time of a. So from here you can see the value of n1, n2 and n3, these are 1 2 and 1. So here you have n1 is equal to 1 and n2 this is equal to 2 and n3 this is equal to 1. Now you will take their reciprocal. So the reciprocals you will take now. So reciprocal will be 1, and then reciprocal of 2 will be 1 by 2, and that of 1 will be 1 by 1. So now you will remove the fractions. If it is there, then I will remove fractions, then it will become 2 1 and 2. Okay class. So these are the Miller indices. These are the Miller indices for this particular phase.
Stop.
Okay class. Now see, this is a cube, and if we take a plane which is, come here first, we have a plane which is passing through these corner lattice points. Now you can tilt this plane either towards you or towards z direction. Okay. Now the third case, in the third case, you will find this example in your book. The face, this face is tilted towards z. Okay. So in that case, what will happen? It will cut the z axis. Okay. Suppose it is passing through a point. This is the point where it is cutting the z axis, and this is the plane. So you can see what is happening here. Okay. Now what are the coordinates here? You will see the size of the cube is again a. Okay, and this side is will be a. So the coordinate of this point will be a, 0 and 0, and that of this point, the coordinate of this point will be 0, a, and then 0. Now come to the z axis. For this axis, this side is a and it is in the middle, so this point is at a distance of a by 2. So the coordinate of this point will be 0, 0, and a by 2. I can write this. Okay class. Now this is the plane, and if I rub this cube, then see, it looks like this. You can do the same thing in the rest of the cases. Okay class. So this is how the plane is there. Okay. This is the plane. Okay. So this is the plane, and this is intersecting all the axes. Okay. So class, first of all, you will find the intercept along the x direction. This is 1 time of a, and along the y direction, this is 1 time of a, and then along the z direction, this is half time of a. So this is a particular case where we have taken an intercept at a distance which is less than the length of primitive axis along a particular axis. So this is the first step. Now we will see what are the values of n1, n2, n3. So here the value of n1 is 1, that of n2 is 1, and n3, this is half 1 by 2. Now what you will do, you will take a reciprocal of these. Reciprocal of 1 will be again 1, that of 1 it is 1, and that of 1 by 2, this is 2. Now if there is any fraction, then you will solve it, otherwise it is okay. So class, these are now put in parentheses. So the Miller indices for this plane will be 1, 1, and 2. Okay class, so this is the end of the video lecture. In the coming video lecture, we will discuss the features of Miller indices. Thank you class.